When you tap a link on your phone, how does that request find the right computer on the other side of the planet and get the information back to you in just a few milliseconds? Out of the billions of devices online, the internet knows exactly which one belongs to you. It works because all these different machines have agreed on exactly how to talk to each other. They essentially follow a shared set of handshake rules, so they never get confused when passing information back and forth. This shared agreement is called a protocol. This diagram shows a standard IPv4 address. It's a numerical identifier made up of 4 blocks of numbers separated by periods. Every single device, from your laptop to a giant web server, is assigned one of these unique labels. These numbers function exactly like a physical mailing address. Just like your house number, street, city, and zip code tell a mail carrier where to drop a package, an IP address gives your data a specific destination to reach. Without this definitive delivery location, the internet would be useless. It wouldn't be able to route a single email, video, or message to the correct person. But there's a catch. Your internet provider only gives your home or business one single public IP address. However, you likely have phones, laptops, and TVs that all need to be online at the same time. Think of your home network like an apartment building. This diagram shows the single public IP address acting as the main street address for the entire building. Inside, each of your devices is assigned its own unique private IP address. These private addresses are like internal apartment numbers. They are unique within your specific building, allowing your phone to find your wireless printer, but they stay hidden from the rest of the world. To bridge the gap, your router acts like a mailroom clerk. When a device inside the building sends a request, the router intercepts it, swaps the private tag for the public street address, and sends it out to the internet. This process is called Network Address Translation, or NAT. When the response comes back, the router remembers which device asked for it and sorts it to the correct department. This allows dozens of gadgets to share just one internet connection safely. Now, big websites live on servers that need permanent, static addresses, so they can always be found at the same spot. But your personal devices don't need to keep the same address forever. Instead, your router uses DHCP to automatically hand out temporary, dynamic addresses, distributing these digital tags the moment a device joins the network. When you disconnect, that tag goes back to the router for the next person. This automated recycling prevents address conflicts and lets the network manage a constantly changing crowd of devices without you ever having to lift a finger. The original address system was built like a combination lock with a limited number of dials. Because those addresses were only a certain length, the system could only create a maximum of about 4.3 billion unique combinations. As the world added billions of people and even more smart gadgets, from watches to streetlights, we eventually ran out of those original addresses. The solution is IPv6. By adding more characters, it creates vastly more combinations. Instead of 4 billion, we have a number with 36 zeros after it, enough to give a unique address to every single grain of sand on Earth. This massive expansion means we'll never run out again, ensuring that every new device invented in the future can connect directly to the global network. Handling all these addresses takes global coordination. The master list is managed by a central group called IENA, which makes sure the numbers are handed out in an organized way. This map shows how IENA divides the world into 5 regions. Each region has its own registry that manages the address blocks for that specific continent, eventually trickling down to your local internet provider. Because these addresses are tied to specific regions and providers, they do tell websites a little bit about you, specifically which company provides your internet and your general city or region. However, this isn't a tracking device. An IP address alone cannot tell a stranger your name, your phone number, or exactly which house you live in. At its heart, the IP address is the backbone of the internet's delivery network. It's the silent, numerical system that ensures every piece of information you ask for reaches your screen exactly when you need it.